All right, so if we're finding the local max and min for a polynomial, what we want to remember is that any local max or min that will occur will be at critical numbers, right? So the critical numbers are where the derivative is going to equal 0. So to find local max and min, given a function, we want to find the critical numbers. So we'll first find the derivative. So f prime, power rule here, so it's going to be 12x squared minus 18x plus 6. And I want to find out where that's 0. Now, if you can simplify this at all, that'd be great. If you can divide out a common factor. It looks like I can divide out 6 from all these, right? So it's going to be 2x squared minus 3x plus 1. So this is a quadratic. We might be able to factor this by sight. So you want to probably attempt that. You can do this by intuition. So 2x squared is going to come from 2x times x, and then 1 is going to come from 1 times 1. So we just have to work out the details of the signs. So this looks like a minus 2x and a minus 1x. Gives us a minus 3. So are you okay with this as being the factored form of that? Okay. All right, so the critical numbers are going to be where each of these factors equals 0, right? So that's going to be x at 1/2 and x at 1. And again, what I did, just shortcut there, is change the sign, put this number over this number. Positive 1 over 2. Change the sign, this number 1 over 1. Okay? So those are the critical values. So let's see, we have some options here now. What you can do is you can do sign analysis, which shouldn't be a problem for the derivative, because remember, if we can figure out where the derivative is positive and where it's negative, that will help us to know if it's positive and then 0 and then negative, that's a local max. If it's negative, then 0 at a critical number, and then positive again, that's a local min. If it's positive, 0 positive, that's neither. If it's negative, 0 negative, neither, right? So we could do sign analysis. That's option 1, sign analysis. And that would be simply examining what the derivative looks like. So you put each of these factors in there. This down here at the bottom is a number line. You put in 1/2 here. You put in 1 here on the number line in proper order. And then you do your sign analysis. So I'll do that real quick. 2x minus 1 at 1/2 is 0. And before that, it's going to be negative. If you just pick any negative, like a 0. So 0 minus 1 is negative 1. And then positive afterwards. And then this one is going to be at 1 is going to be 0, and negative ahead of that, and positive after. So that means that the derivative is going to be positive here. Yeah, negative, 0, and positive. So that's great. That tells me that we have positive slopes for tangents, then we have a 0 slope, then we have negatives. And that looks exactly like a local what? A max, right? Because the function's going to be under here somewhere, right? So that's a local maximum right there. And then here, negative, 0, positive. Well, that's a local min, right? Actually, it would be above, I guess. Ooh. Yeah, so the function would look something like this, come under there, and then it would go on top of those ones like that. So yeah, so we have a local min. So there you go. You can say, now the only other thing is you would say, f of 1/2 we said was a local max. So you'd have to also find the y value there to make that, okay, and then local max. So you should put the points, the x and y value there. And so that's a local max. And then f of 1 is whatever that number is, that's local min. Now, that's option 1. That's the first thing we learned. So back in chapter 4, early chapter 4, maybe that's what we learned, the sign analysis. We also, I think it was maybe in chapter 4 as well, maybe towards the end, we talked about the second derivative test. So the option 2, and in a polynomial, it's pretty easy to do the second derivative test. So let me just erase all this. Okay, I'm going to erase all this, and I'm going to show you the second derivative test is finding the second derivative and inserting your critical values in there. Remember that? So the second derivative test would be find the second derivative, which is really easy with a polynomial. So here's our first derivative is simplified here. I guess you could do it. You could do this one. That's technically the first derivative. So in case you're wondering, you can go 12 times 2 is 24, x minus 18. And of course, you could factor 6 out of there. We let that equal 0. And so that's going to be 4x minus 3. Now, actually, we don't need to equal 0 here. This is the simplified version of this. I'll factor it. So if you put in, so now what we're going to do is we're going to put in f double prime of our first critical number. And we're going to find out if it's positive or negative. So that's 12 minus 18, that's negative. Okay, so that means that the function is behaving like a negative. It's got a concave down character to it at that point. So if it's a concave down character, guess what? That's going to be a local max, which I erased it, but that would line up with our sign analysis. And then you plug in f double prime of 1, and that's going to be 24 times 1 minus 18, which is a positive. So that is a concave up characteristic of the graph there. So you know that that's now a local min. So there's the two ways of finding your local min from a polynomial. It's pretty easy. You can do both tests. If you have some kind of rational function, or if the derivative is a ratio, probably the sign analysis would be best. Just put the factors on there. You might have to divide and so on, just positive divided by a negative, or make sure you divide by 0, it's undefined, so there's no point there, whatever. But yeah, so those are your two options for that.
Thanks.
That's good, yeah. Anybody else have any questions on this or anything like this that you want to ask about?